Welcome everybody to Avoiding Reactor Meltdown. My name is Philip Clay. I work at Blizzard Entertainment and I'm a principal software engineer, and today we're going to be talking about successfully blocking in a reactive world. And if you haven't seen some earlier talks about this, you've kind of seen some hints at blocking, a lot of mention of blocking already at the conference. If you haven't already watched or didn't attend the Reactor Do's and Don'ts, there's about a 5-minute section on blocking in there. There's a lot of other awesome content in that talk, so please watch it if you didn't get a chance to attend here. We also saw this morning at the keynote, you saw Stefan and Violetta talk about, or you saw them like introduce BlockHound, and you saw some BlockHound in action a little bit. So I'm going to dive in a little bit deeper in blocking in this talk. So think of it as just an expanded section on blocking. So specifically, I'm going to talk about why we need to block sometimes in reactive applications. Then I'll go over some architectural level and service level solutions for how you should block and how you should block successfully and correctly. Then we'll get into a little bit lower level details with some coding concepts, and I'm going to go through a live demo that basically where we find an application, we have an application that's blocking incorrectly, we find where it's blocking, and we fix it. And at the end, I'll leave some time for Q&A. Should be plenty of time, so please hold your questions until the end, and I'll be sure to get to them. Appreciate it. All right, so before I start, really, I want to give a little bit of background on where this talk is coming from. I work at Blizzard, like I said, and Blizzard is first and foremost a games company. We make games. I hope you recognize a few and have an opportunity to have played them in the past. If not, give them a try. They're pretty fun. However, this talk is not about games, and it's not about game programming. Instead, this talk and the background for this talk is really about the ecosystem of services that Blizzard has around the games. You might recognize some of these. They're very common. They're not specific to the game industry, so a lot of this will apply to you as well. So these are the types of services where we're kind of strategically introducing Reactor where it makes sense. We're definitely not rewriting all of our blocking style applications in Reactor. That doesn't make sense. But where it makes sense, we're trying to figure out, okay, could we take advantage of the advantages that it has and kind of strategically introduce it. So just a couple of examples of what we have at Blizzard. We have an API gateway. We have a developer portal that gives our community access to our APIs and our game data. We have commerce systems that back our in-game shops, our web shops. They integrate on the back end with countless payment providers around the world. We have many, many, many internal services that back our internal tools that help us manage things like our players, our product catalog, promotions, everything, you name it. So to give you an idea of where we're actually using Reactor today, our API gateway is currently using it to help manage some of the back pressure and some of the streaming APIs. Our recently renovated account management portion of our website uses Webflux, and it recently just went through a very high load event, the first high load event that we've really had on that, and that was the release of World of Warcraft Classic about a month and a half ago, and it handled that like smooth, completely like butter. And if you've seen, I think Stefan and Violetta also had another talk where they were talking about how Reactor scales. We saw basically the exact same graphs that they showed during their talk. So it was, handled it great, scaled really well. We also use RxJava on our mobile apps, so not Reactor, but still reactive streams. And we're also introducing Reactor in some of our service-to-service communication. Particularly, we're using web client, WebSocket client from Webflux, and we're also starting to use Reactor RabbitMQ. So that's where we're doing today, and that's kind of the background of where this talk and where all the experience comes from. So the first question you might have is, why are we talking about blocking? Isn't reactive supposed to be async and everything's great in the world, we don't have to block anymore? Well, unfortunately, as you all probably know, not every single library that's out there provides an async API. Sometimes if we want to take advantage of some functionality that someone else has written, we have to call a blocking API. And you don't actually have to look very far outside of Java itself in order to find instances of this. Like take, for example, secure random. It's a very basic building block of all kind of security, cryptography, all that stuff on the JVM. It only provides a blocking API. So even if you're not using it in your application, chances are you're probably using a library that's using secure random. So it's a blocking API. We have to figure out how to deal with it in our applications and in our libraries that use it. Also, there's Sergey actually gave a really good example of some libraries that provide async APIs that are documented as fully async. But if you actually call them, you'll notice that sometimes they'll block under certain conditions. So either it's a bug, either it's a design flaw, something. Sometimes we just have to work around that behavior. And if you've been around long enough, you probably have worked around bad behavior in libraries before, so that's nothing new. We have to work around things sometimes. So that's kind of another reason why we have to block. And I really want to call out, it's not necessarily that we want to block. It's more along the lines of we have to block because there's no other option. Hopefully this will change in the years to come as Reactive gets more adoption. There's more support in all of our libraries. But until then, we kind of have to live in this kind of weird world where we have to mix our async implementations with blocking APIs. So that's why we block. Now we'll get into some blocking solutions about how you should actually block in your reactive streams and reactive applications. But I first want to mention a message, and repeat this message from Pivotal that we've been hearing since Spring 5 came out. And that's make sure you choose the appropriate threading model for your application. We all know we're very familiar with the blocking thread per request style. In the Spring ecosystem, we've been doing that for a long time with WebMVC. And now with Spring 5, we have the new non-blocking style event loop with Webflux. And again, blocking style has many, many threads. Event loop, you just have generally a number of threads roughly equivalent to your number of CPU cores. So if you're writing a service and 99% of the time you have to call blocking APIs, don't use Webflux. Don't use the parallel event loop style. You'll make your life way harder than it needs to be. Just go ahead, use WebMVC, because that's going to be more appropriate for your application. If, on the other hand, you have the luxury of calling APIs that are async or reactive, you have the option of using Webflux. You still don't necessarily have to use it because it might make sense to use blocking just because maybe that's where all your experience is, whatever. There's lots of reasons comparing back and forth. I'm not going to get into all that here. But you do have the option with non-blocking. And what I'm going to get in today is if you have selected Webflux or if you have selected a non-blocking style and occasionally you have to make blocking calls, that's really the use case that I'm going to talk about here. So I'm going to go through a scenario. In this scenario, we have three services. We have our main service that I'm going to talk about, which is this service A, and it's happily living its life in a non-blocking manner. It's got a parallel event loop, it's Webflux. It's happily calling downstream services with service, in this case, service B and service C. And maybe it's using web client to call them. Who knows? Maybe it's using RSocket. It doesn't really matter. One day, we get a new requirement, and we have to talk to a new service. But unfortunately, in this scenario, the only way to talk to that new service is with a blocking API. So we've run into this in several situations, but maybe this is a third-party service, and they provide you an SDK, and that SDK is 5 years old. It only provides a blocking API. You kind of have to use it. It happens. Or maybe service D isn't really a service at all. It's just a relational database that you want to try to hook in, and maybe it's not. Maybe you're kind of stuck with JDBC for a little while. And again, maybe it's not really the primary path of service A, not where all traffic is going to hit that database. Maybe it's for some sort of side channel data or something like that. That's really what I'm talking about. So we have to call this service and deal with it. And I really want to start out by pointing out what not to do. This is what we're trying to avoid. Do not call that blocking API from your event loop. If you do, basically what's going to happen is you have a very limited number of threads in your event loop. So if you have a very high concurrent requests incoming into your service, then that event loop is basically going to stall while it's waiting on blocking. So this is what we're trying to avoid, is kind of freezing up your event loop. And in hindsight, I probably should have titled this talk Avoiding Reactor Freeze Up, but Meltdown is a much catchier word for whenever you're talking about reactors, so I went with a much catchier word. But yeah, so don't do this. So what should you do? I'm going to give you a couple solutions. This first one is more of an architectural level solution. And that is actually introducing a whole new service to isolate your blocking calls. You might think that's kind of heavy-handed, but there are actually some advantages. One is you're limiting each service to a single threading model. So in this case, we just introduced a new service. It can go ahead and choose that thread per request model, and it doesn't matter that it's calling those blocking APIs on any of the threads that it has, because all those threads are meant for blocking. It doesn't have to worry about bouncing back and forth between different thread pools or anything like that. Also, it keeps service A a lot cleaner, because there's one simple rule in service A: don't block. If you see blocking code, if you're tempted to introduce blocking code in that service, it's wrong. If you see it in a code review or whenever you're pair programming, it's wrong. Fix it. It's a bug. Again, you don't have to think about, is it okay to block in this certain situation? No, it's not okay. You never block in service A. And we've done this at Blizzard. In particular, our API gateway is fully async, and we've had to kind of isolate things like this in the past. Now, you might also want to consider other kind of architectural advantages that this gives you in addition to just blocking. Particularly, like, take that example where I was giving you earlier, where maybe service D is a third party or something like that. Introducing a new service in front of it might give you somewhere to do some caching, or it might give you somewhere to do some better circuit breaking because maybe your connection to that third party service is kind of flaky. Or maybe you just want to provide a better interface into your internal applications to that third party service. So there are other kind of architectural concerns that can be solved by introducing this new service, in addition to just kind of solving your blocking problem. Of course, just like everything in computer science, there's also disadvantages. You can kind of probably already predict some of them. One is you're introducing a new latency. Another is you're introducing a new service, so now you have to manage that separate service. And how difficult that new service is to manage might kind of just depend on how well your organization, or how far along your organization is as far as, you know, how far you've gone down the microservice path or not. Like, if you have 100 microservices, 1,000 microservices, another one's probably not that big a deal because your processes are optimized already so that it's not, you know, it's not going to be much overhead. But if you're on the other end of the spectrum and you have 10 services and you're adding an 11th, you know, it's going to be a little bit harder. So I'm really bringing the solution up because it's not talked about a lot, but it is something that you can do. It's something that we have done at Blizzard, and we've done it with pretty good success so far. So the second solution is one that we've heard several times at this conference, and that's basically isolating all of your blocking calls to a separate thread pool within the same service. So you can see in this chart, we have service A. It has two different thread pools, one for our event loop, which has, again, roughly equivalent number of threads to the CPU cores. And we have kind of another thread pool for all of our blocking tasks. And we just have to make sure that all the blocking is isolated to that thread pool. The good news with Reactor is Reactor provides a really nice facade, really nice abstraction on top of those thread pools called schedulers. And we've all seen some of that in some of the demos already. But in Reactor, the scheduler that's meant for event loop is called a parallel scheduler, and the scheduler that's meant for the blocking tasks and the most recent version of Reactor is called the bounded elastic scheduler. There used to be an older elastic scheduler, but that one's kind of going away. So this has some advantages in that, you know, you're keeping everything in the same service. It kind of simplifies it from that architectural perspective, but it also has some downsides as well. The first downside is really that your engineers have to be very disciplined about where their blocking code is running now. They have to be very aware of the threads that they're running on, that blocking code. So think about that like from maybe a code review perspective. So in a code review, you're generally looking at a small diff of what has changed, and you might not have the full context about that code, about where that code is running. It's not immediately obvious like which thread a particular, you know, 3-line segment of code review is running on. So it's harder to detect this at code review time. So yeah, there's a lot more discipline that kind of is involved about moving that blocking call, putting it on the right scheduler. You have to just be very aware of it. Another thing is managing context. Take, for example, if you're in an application, a traditional kind of WebMVC application that uses this thread per request model, you have context in the form of thread locals. That's kind of behind the scenes for you. That's where the Spring Security context is. That's where the SLF4J MDC is. It's behind the scenes. It's not generally in your face whenever you're writing your business logic, and it's generally taken care of by the frameworks and the libraries that you use. The same on a Webflux style application. If you have a Webflux only that's purely reactive, purely event loop driven, and you're not doing any blocking calls, then all that stuff is handled by the Reactor subscriber context. Same sort of situation where it's kind of behind the scenes. It's there whenever you need to access it, but mostly it's just taken advantage of and used and managed by the libraries that you're using and the frameworks that you're using. However, if you shove these two things in the same application, now suddenly you have to think about the context. You have to think about propagating that context from one scheduler to another. A lot of this can kind of be simplified a little bit with scheduler customization, scheduler hooks, as far as taking things out of the subscriber context and putting it on thread locals. But that handles the simple cases. It doesn't handle all the cases. So a lot of times it's more in your face as far as like trying to propagate that stuff. So it's more just your responsibility to handle that now. So because this solution is the more complex solution, this is more of the solution that I'm going to dive into a little bit further whenever we get into code and the live demo here. And speaking of code, let's go through some coding concepts. And I want to start this section by saying that I'm a really big fan of self-documenting code and the principle of least surprises. And both of those two concepts relies on kind of the implicit assumptions that we make whenever we're reading a small bit of code. So what I want to do here is I want to show you a small bit of code, and we're going to make some assumptions about it together. And the reason I want to go through this is because code that follows those assumptions, that's generally your correct code. Code that doesn't follow those assumptions, that's generally where you have those bugs, because the people that are using your APIs are making those assumptions, whether you like them to or not. And if you're not kind of following those assumptions, that's where bugs kind of crop up. So first example, pretty easy example. We can take a look at the input arguments for this method. We can take a look at the return value, and then we obviously know that this is a synchronous method. And we know it's synchronous because there's no async concepts being used. There's no callbacks. There's no futures. There's no promises. There's no publishers. There's no monos. There's no fluxes. So we know it's synchronous. And then we can look at the throws clause, and we can see that this is a blocking method because interrupted exception is what happens whenever a thread that is blocking is interrupted by somebody else. So we immediately know that it's blocking. And because I know it's blocking, I know that if I want to call this method from a reactive stream, then it's my responsibility to make sure that that work is performed on the right event loop. It's not this method's responsibility. It can't do it. It doesn't have the means of scheduling that work because it has to return results synchronously. So it's my responsibility as a caller. Second example, very similar to the first. Again, we know that it's synchronous for the same reasons. But I put this in here specifically because it's very common nowadays for that interrupted exception to be wrapped in a runtime exception, and it just kind of disappears from all the method signatures. Very common for libraries to do this, very common for you to do this in your code. So unfortunately, we're kind of missing some of that self-documenting code, so we do have to rely on documentation. We do have to rely on looking at implementation sometimes. So we don't really know if this method is blocking or not. And again, if this method is blocking, it's my responsibility as a caller of this method to make sure it's run on the right scheduler. So the last example here is we can take a look at that return value. We see that it's a mono. That's a reactive type. That's a publisher that emits 0 or 1 values. And so we know this is a reactive method. And because it's reactive, and because one of the kind of main principles of reactive streams is that no work happens until you subscribe, I'm making the assumption that this method is not going to do any significant amount of work until I subscribe to that returned mono. And because I'm making the assumption that no work is going to happen until I subscribe, I know that this method is not going to block if I call it, because blocking is significant work to me. Should not happen. So again, this is my assumption that I'm making about the method. And the last assumption is, since this method has access to reactive streams, it has access to the Reactor API, then I'm going to make the assumption that it's the method implementation's responsibility to make sure that any blocking work happens on the right scheduler. And that's because like Reactor, and whenever you're kind of constructing your chain, your mono to return, it gives you easy access to the API to put that work on another scheduler. So again, it's the method implementation's responsibility to do that. It's not my responsibility as a caller. I should just assume that any reactive method in my application I can call safely from anywhere. Think about that for a second. That's what we're trying to achieve. Because if you have reactive methods that don't schedule their work properly, that's where you get landmines in your application. If you happen to call that method on the wrong scheduler, you're going to lock up your event loop. So now that we've kind of gone through some assumptions, I want to define a few terms. And I find that having a common vocabulary for some of these assumptions makes it a lot easier to talk about with your kind of fellow engineers, a lot easier to identify on code reviews, a lot easier to identify when something is correct versus not correct. So the first term that I'm going to define is what I'm calling an imposter reactive method. So this is a method that looks reactive. It has a method signature that returns a reactive type. However, if you were to actually look at the implementation of that method, you would see that it's really just implemented synchronously. And one of the kind of dead giveaways for an imposter reactive method is at the very top of the method, you have a whole bunch of logic, so doing a whole lot of work up front. And at the very bottom of the method, you have a return value that returns mono.just and then some pre-computed value. And sometimes you even have a try-catch around that, and in the catch block, you have mono.error, and then the exception that was thrown. So you're doing all the work up front, which is what I just said we shouldn't do. But you're doing all the work up front, and you're not really doing anything reactive. You're just doing it a synchronous method. There's really no reason for this method to be synchronous if you're going to implement it like that. Just make it a synchronous method. So the other term is, that I've been using is called blocking encapsulation. And we're all familiar with encapsulation from whenever we learned object-oriented programming way back when. And encapsulation is just the idea of hiding all of your internal state, hiding all of your guts so that everybody else doesn't have access to it, so I can change it and access it as needed internally. The same concept can be really applied to blocking. And this is what I'm kind of referencing whenever in the previous slide about it's the method implementation's responsibility to make sure blocking is done on the event loop. If you have all reactive methods and they all internally, at the lowest level, whenever they're making a blocking call, if they schedule that work on the appropriate scheduler, then that method has properly encapsulated blocking. If you allow that blocking knowledge to escape that reactive method, then you haven't encapsulated it, and you're kind of requiring that all the callers do something about it. So blocking encapsulation, good. Imposter reactive method, bad. So now we've gone through some terminology, we've gone through assumptions, we kind of have a common level set about the code we're going to look at and some things that we could look for whenever we're looking through this demo, and now it's demo time. So all this code is available on my GitHub, and we will go to the demo. All right, we have our favorite Hello World application. Yay! And there was much rejoicing. So basically, I just have this simple web application here. Whenever I hit the hello endpoint, it's going to return me a greeting in a random language. And I got all these languages online, and I hope none of them are bad words. So you can see it's working, but I'm going to go ahead and tell you that this application does blocking incorrectly. So I'm going to spoil the fun. And what we're going to do in this demo is essentially we're going to find where it's doing that blocking incorrectly, and then we're going to go through a process of trying to correct it. And I'm intentionally going to correct things wrong first, because I really want you to see kind of the patterns that are used and the patterns that you should identify that are wrong first. It's very helpful to see those up front so you can find out what's wrong versus what's right. And then at the end, we'll end with a successful application. So again, you can see it works. And just a quick tour of the application. What we have right now is just a simple Spring Boot WebFlux application, not much to it. I'm using Lombok to simplify some of the code. Here's our Spring Boot main class. Again, not much to it. I'm pulling all the configuration values or the responses from this configuration properties. We have a controller. We're using kind of the mapped style pattern as opposed to the functional pattern. And we have a single endpoint, and this single endpoint delegates to a greeting service. And the greeting service, we can look at the method signature, and from earlier we can tell this is a synchronous method. It doesn't throw interrupted exception, it just throws exception. But thankfully, whoever wrote this method documented the fact that it blocks, so we know that this method blocks. The greeting service is, we're going to treat that as the API that we can't touch, we can't change. This is your third-party SDK, this is your standard JDBC API, this is some sort of blocking code that you can't change, you don't have access to it. So what we're going to do is we're going to code around it. We're going to make it block, we're going to make calls to this interface block correctly. So the first thing we really need to do is find out where it's blocking incorrectly. So let's do that first. And I'm going to use BlockHound to do that. You saw BlockHound introduced earlier today, and I'm going to do the same thing here. It's very simple to introduce BlockHound. You basically just add a dependency on it, and then in your main application, you just install the agent. So it's very simple to install, very simple to set up. Now, BlockHound is a really elegantly written piece of software. It's very customizable in what it can do. You can customize the methods that it wants to identify as blocking. You can whitelist certain methods. You can change the behavior of what happens whenever a blocking call is made. You saw earlier, it basically will throw an error whenever a blocking call is made on an incorrect thread, on a thread that's meant for non-blocking tasks. So say you wanted to just log that happened instead of throwing an error. Well, you can do that if you want to customize it. And it's also pretty smart in that it has basically a concept of integration, so plugins. Basically, it'll go out and find all the integrations that are available in the class path. And one of the integrations happens to be for Reactor. So it knows, that's how it knows about Reactor. That's how it knows about the Reactor scheduler. It also has an integration for RxJava. I think there's one for Netty as well. And you can write your own integrations. It's a very, very cool piece of software. But again, it's just instrumenting the blocking calls, and then whenever that blocking call happens, it's looking to see what thread it's running on. If it's a thread that's meant for only async tasks, then it's going to do something. But the default behavior is to block that call to, that's a wrong choice of words, to throw an exception instead of allowing that blocking call to continue. In the demo, I'm just going to install kind of the default behavior. So this will go out and dynamically figure out that, hey, I'm using Project Reactor, and configure it for Project Reactor. So what I'll do is I'll restart the application with BlockHound installed. And we will execute our endpoint again. And we can see that now it has found that there is a blocking call that's being made incorrectly. In this case, I'm using thread.sleep, but that's just my demo code. That could really be any kind of blocking call that is made. So let's go over and look at the server side, what happened for that. And we'll see that here you can see our controller was called. It called back into my greeting service implementation, and then that greeting service implementation called thread.sleep, because I'm just kind of simulating a blocking call. And you can see the instrumentation kick in here where the BlockHound runtime is checking the blocking call. It found the fact that this is blocking, and it's looking at the thread to see which thread is actually executing that blocking call. And in this case, it finds that it's running on this HTTP NIO thread, which is a thread that's only meant for async tasks. So because of that, it's going to throw an error instead of allowing that blocking call to continue. So this is a good thing. We're not blocking our event loop. So now we need to fix it. Let's go back and look at what we have. We'll go back to our controller. And I really want to point this out. This controller, if you're from the WebMVC world, it looks perfectly correct, right? This looks exactly like a WebMVC controller, synchronous method. What's the problem? Well, the problem is, obviously, Webflux only has a very small number of threads to call this on, and it's going to call this method on the event loop. So even though Webflux allows you to call synchronous methods like this, it's very dangerous. Be very, very careful whenever you're using synchronous methods with Webflux. In our kind of situation, we found it's so easy to introduce a blocking call into those methods because it looks correct. It looks just like WebMVC, just like you have been using for a long time. So in this case, this blocking call is Webflux is calling this method on the event loop, and we're calling this blocking call, which is incorrect. So our first attempt, what we're going to do is, again, this is the greeting service that I was mentioning earlier that has the blocking call. What we're going to do is we're going to create a greeting reactive service that wraps this service. So I'm going to create a new interface. We'll call it the greeting reactive service. We'll create an interface. And I'm going to create the equivalent method for the get greeting. And since it returns a single value, we're going to return a mono. Get greeting. And we're going to go back to our controller, and I'm going to change the controller to use that greeting service. I'll implement the interface in a second. So we'll change this to greeting reactive service. We'll rename this because we're good Java citizens. We'll change the return type to a mono instead of the string, and I'm going to get rid of the throws exception. So I've switched the controller over to be a reactive style application, or a reactive style method now. This hello is returning a mono, and it's returning the get greeting. So now I actually need to go implement this get greeting method. And I'm going to create an implementation here. So we've got our implementation. This needs to wrap the synchronous greeting service. So I'm going to give it one of those. Greeting service. And I need to specify that. So I'm going to use lumbock to create the constructor. And annotate that it is a service, so Spring picks it up as a bean. And now we've kind of got our playground to mess with. So this get greeting method is the reactive method that we want to make sure delegates the blocking work correctly. So I know I need to call greeting service.getGreeting, so I'm going to go ahead and just type that out. And the first thing that newcomers to Reactor always do is their favorite thing to call, I've noticed, is mono.just, because that's the most familiar thing that you can do whenever you're coming from the imperative world. So we're going to pre-compute that value. Hint, spoilers, that's what we're not supposed to do. But this is our first attempt at fixing it. And IntelliJ is telling me here that I forgot to handle the exception, so we're going to surround this with a try-catch clause and return mono.error. All right, so this is our first attempt to fix the problem. We're making the method reactive. We just made it reactive. That's going to solve all of our problems. So if you remember the definitions from earlier, I'm going to go ahead and point out this is an imposter reactive method. So this is a method, if you were to just look at the signature, it looks reactive, but we're doing all kinds of work up front, which is our blocking call. Maybe that's calling some downstream service, something like that. We're doing all of that up front, and we're just returning the result of that, the pre-computed result. I want to show, I'm going to turn BlockHound off real quick to begin, just to show something up front. So one of the downsides of this, let me bounce back. There we go. One of the downsides of this is that you're really limiting what you can do with this return to mono. If you remember, even from Sergey's earlier Reactor do's and don'ts, there's other operators that Project Reactor provides you to provide some more resilience, like a timeout operator or a retry operator, or something that you can add downstream to add a little bit more resilience to your code. So in this case, say this get greeting service is a downstream service, and we had like some sort of transient network problem, and we wanted to just retry, or we wanted to use a back-off retry. Well, if we were to add a retry operator to this return mono, then we wouldn't actually retry, because that value is actually computed up front. It's not going to recall the get greeting method. What it's going to do is it's going to resubscribe to the mono. And in this case, since the mono only knows about that pre-calculated value, it can't go and re-execute that logic again. It can't do a retry, or it can't do a timeout, because you're blocking before the stream actually starts. So that's a problem, and I want to just show that real quick. And what I'm going to do is I'm going to introduce another endpoint called hellos. And in this hellos endpoint, I'm going to use the repeat operator. And the repeat operator is very similar to retry, except repeat basically will resubscribe on success, and retry will resubscribe on failure. So what I would expect, and what I would assume if I were to look at this code, would be I would get 5 different greetings. I'll get the original one, and then I'll get I want it to retry, basically, or repeat 4 more times, so 5 total, and I would like to have different greetings for that. But, as you can probably predict, if I go and execute that endpoint, what I get is just the same pre-calculated value that happened before I even subscribed to the mono. We just get that same value repeated every time. So there's no way to use the repeat operator, there's no way to add more resilience to this API by retrying or adding timeouts, things like that, because all that work is done up front. So that's what, we'll say attempt number 1 is a fail, big fat fail. So now, the first problem I want to solve here is let's make this not an imposter method. And I can do that by utilizing another kind of static factory for creating monos called mono.fromCallable. From callable, select the right one. And from callable takes a callable, as you can probably presume there. And what it'll do, IntelliJ is smarter than me, so I'm going to replace this with a lambda. Basically what this happens is for every subscription to this mono, it's going to re-execute this callable. So every time I resubscribe to the mono, again, it's going to call this getGreeting method. And whatever value that getGreeting method returns, the mono is going to admit that value. And if getGreeting happens to throw an exception, the mono is going to complete with an error. So this is no longer an imposter method, and because it's delaying that work until the subscription happens. So if we restart the application and we hit our endpoint again, remember I've turned BlockHound off, so there's no blocking detection here. We can see if we hit that endpoint, we do get different values, which is kind of the desired behavior. So that is one of the symptoms, again, of the imposter method is just, again, pre-computing that value up front. You're basically limiting yourself to not being able to use those resilience operators. All right, so now I'm going to re-enable BlockHound and show that I have actually fixed the blocking problem. I'll restart it again. We'll hit our endpoint, and we can see that BlockHound is still detecting an error. So if I go back to the stack trace, it looks very similar. Again, we're calling our, here's where our greeting service implementation is being called. It's doing the thread that sleep. Notice that the downstream stack trace here looks a little bit different because that logic is happening on subscribe as opposed to during the assembly time. So that's where if I actually had the Reactor debug agent, you'd be able to, I don't have it installed right now, but if I were to add that, you'd get a little bit more information before the stack trace to get a little bit, better information about where that error occurred. So, all right, so let's go back to our implementation, and let's try to make this better. So actually, I want to go to a different spot. I want to go back up to the controller. All we need to do in order to fix this is make the work happen on another scheduler. Now I'm going to focus on where you make that decision as far as what scheduler to run it on. So say you got a bug report, you need to come fix it. You said somebody is hitting our hello endpoint and it's blocking our event loop. Let's fix the problem. So we can do that up here in the hello method of our controller, and we can say I want to do this work on another thread or another scheduler. Schedulers.bounded elastic. So the subscribe on operator essentially tells the reactive stream that whenever a subscription happens, instead of subscribing on the immediate thread, instead of subscribing on the thread of whoever invoked the subscribe method, instead subscribe on this other scheduler. So this is how you schedule blocking work on another scheduler. And again, a really simple API that Reactor provides in order to be able to bounce back and forth. There's another API called publish on, but that happens for everything downstream. The subscribe on really happens for everything upstream. So this is the getGreeting method. So let's restart our application. Again, BlockHound is still enabled. So if we hit that hello endpoint, we'll see that we fixed it. Blocking is happening on the correct scheduler. However, if we hit our hellos endpoint, we haven't fixed that one yet. So we only fixed one endpoint. So one solution to this, obviously, is the good old copypasta method. And I know as soon as I do that, I felt everybody cringe. I felt it. So you can start to see something is a little wrong here. Sorry. No. Yeah. Yeah, so yeah, everybody kind of knows already that this is not the best way to do it because we're starting to repeat ourselves, and that's the one thing that all engineers hate doing, is repeating themselves. That's the one thing that all engineers hate doing, is repeating yourself. So it's not just a problem because we're repeating ourselves. Even if I were to remove this hello's endpoint and just leave the code for the hello endpoint here, it's still not quite right. And this is the concept of blocking encapsulation that I'm talking about, because the getGreeting method in our service is not properly encapsulating the fact that it's doing blocking work. So now if we were to leave this as it is, that getGreeting service, that getGreeting method call is really, it's a landmine sitting in our application, because if we happen to call that from the wrong thread, if we happen to subscribe to that return mono from the wrong thread, boom, your event loop blows up. So you can probably, you're already probably one step in front of me, but the real solution to this, and I can't get the thing right, the real solution to this is to push that subscribe on down into the service, into our service. We'll go into the implementation. And this is our, I think, 4th attempt at fixing this. So we'll go ahead and run it and see what happens. But this is going to fix our problem. So we'll hit our hello endpoint first. There's our greeting. We hit our hello's endpoint. And again, BlockHound is enabled, and it's not detecting any blocking problems. So we can see we fixed the problem. Now, if you were to go and you were to look at the Reactor user guide, this is almost the example verbatim about how to wrap a blocking call. But what's not in that user guide is all the ways that you can fail trying to do that, trying to get to this. And those are the patterns that we see in our code. We see it, and we have to fix it. Like, we have to identify whenever that's a problem and fix it. Or you can rely on BlockHound to find it. You can find it, I guess, but you kind of have to know why that's the incorrect case. Now, before I end the demo, I want to actually show you some real, genuine Blizzard code here. You saw it first, folks. All right, so this was some Blizzard code. I renamed the nouns. But this was some Blizzard code that we found, and we happened to find it before prod, so that's yay. But what this method was doing was it was removing a bar from a foo. And the way this method was implemented was it would make this downstream service call to remove the bar, which was a synchronous blocking call up front before you subscribe. Then, again, here we see our try catch, and we were returning mono.error. So this is an imposter method, in addition to not blocking correctly. It's an imposter method. And then at the end, it was just returning another method call about sending some kind of event. So it gives you kind of another view of how this could look in the wild. You know, the mono.just here is not really implied. It's not really shown, but it's just still work that's happening up front. We're doing all kinds of work up front. We're doing blocking work up front. There's no way to schedule this on another scheduler if you do it like this. There's no way to add those downstream resilience operators. So this is just an example of something that we had to fix. All right, so the last thing that I want to show, and this is just coming from patterns that we've seen whenever we're doing reactive code. We've noticed that the reactive methods that have the least amount of problems, the least amount of bugs, the least amount of improper blocking kind of look like this. They look like they basically just have a single return statement, and then they have kind of an operator chain here. So for example, maybe I added a .map, .flatmap, pick your favorite operator here, .filter. But they kind of look like this, where there's a single return value, and there's just kind of an operator chain. And those are the reactive methods that we have the least amount of problems, because generally those are the ones that aren't doing any work up front. What we've seen where we have had the most amount of problems, not necessarily, well, that was the wrong thing to say, but in my code and in other people's code, we have seen a lot of problems, is whenever there's a lot of logic up front. And I've kind of taken to call this kind of the danger zone area. I'm not saying don't do anything ever up here, but just kind of keep it related to just assembling the stream. Try not to do any really advanced pre-calculations again, because that's the type of logic that can't take advantage of those downstream operators. So after you've built that stream, That's where you really want to rely, and you really want to provide the user of your API the ability to use those resilience kind of operators for like the retrying and timeouts and things like that. All right. So we're kind of at the end of the demo. I want to go back and go back over to our slides, and I want to leave you with some takeaways. So the first thing, I kind of started off with this, but definitely pick the right threading model for your application. So this is picking your WebMVC style, your WebFlux style. If you're doing a lot of blocking calls, just go with the WebMVC style. Stick with that. You can call blocking from any of the threads generally that are handling requests, and you won't have any problems. On the other hand, if you are going to choose the WebFlux style, then you have to isolate those blocking calls. And you can isolate those blocking calls either to a separate service, and you can get kind of some other architectural advantages with that, or you can isolate those blocking calls to a separate thread pool. Isolating them to a separate thread pool is a little bit more complex. You have to be a little bit more aware of what's going on within each application. It makes code reviews a little bit harder, makes developing it a little bit harder. You have to think about the context that you're kind of bouncing back and forth. So it's a little bit harder to do, but it keeps everything in one service, and you can keep things simple that way. Whenever you're actually implementing those reactive calls and you're making that blocking happen, make sure to try to avoid doing a lot of work before you subscribe. Don't do any blocking work before you subscribe because, again, there's no way to delegate that work to another scheduler if you're doing it before the subscription time. So don't do much work before you subscribe, and then make sure to encapsulate blocking at the lowest level possible. So like basically right next to whenever your blocking call happens. Because if you do that, then you can safely make the assumption about all of your application code. It's like, hey, I am safe to call any reactive method in my entire application and know that no reactive method is going to block my event loop. So that's the kind of style we're looking for. Anytime we see kind of blocking calls that aren't scheduled the right way, we're calling that out in bugs and as problems as during the code review and things like that. And the last thing I want to mention is definitely, I can't repeat that enough, use BlockHound during your testing. It will find bugs. It will find the bugs during unit tests. It will find bugs during your integration tests. And you will, because with integration tests that we found also, your integration test can function correctly. Just like at the beginning of our demo, we saw that it was functioning correctly because we're just hitting it once, right? A lot of times our integration tests don't throw a lot of load at our applications, so you're not likely to just find the blocking problem or anything like that by just noticing it. So use BlockHound, get it to detect it. And that's about it. I want to leave with one plug. We are hiring at Blizzard, careers.blizzard.com. Go there if you're interested. And we are hiring for positions that use Project Reactor, so we have a lot of fun with that. And again, you can reach me at Philster. That's my Twitter handle and also my GitHub handle. So now, any questions? Sure.
Has the team entertained the idea of doing all their framework and multi-module approach so that all the blocking is in a module that can't be reached? Can't.
Like the Java module system, you mean?
No, well, I'm just talking about SpringOne.
In general. Okay, so the question was basically, have we considered isolating, I guess, all that blocking stuff into different modules that aren't accessible, like outside?
You know your reach is calling out, they can't just call back in. You can't have circular dependencies.
Right.
Forces isolation.
Right. No, we haven't, but that's an awesome idea. Yeah, to just kind of isolate it so they can't call back in. Yeah, that's a great idea. But no, we haven't considered doing that. So, yeah, Sergey. Yes. Wait, you should know all this. Why are you asking questions?
Curious about one thing. When it comes to production,
Mm-hmm.
what did you use to actually see that we have a problem? Because performance is definitely degraded performance, is an indicator, but how do you detect that blocking call was the cause of the problem?
So we haven't found any problems in production yet. Luckily, we've caught our blocking problems before that. However, I will say we're not running BlockHound in production yet. And we were mainly waiting kind of for the release, the official release, the GA release of BlockHound. So now that that has happened last week, thanks to Sergey, we will definitely consider running it in prod. And I'll go ahead and say, like, in your application that has, if it's an event loop only style application, there's no reason to not use BlockHound because there's absolutely no performance overhead because the idea is you're not making those blocking calls. And since BlockHound just instruments the blocking methods, you won't actually hit any overhead of BlockHound. And on the other case, I know there's been some performance numbers for BlockHound that are posted. They're actually really impressive. They don't add very much overhead at all to just your application. So even if you're using that mixed style, we'd probably consider using it in production as well for that. Because I think one of the advantages with throwing an error by BlockHound instead of actually blocking your event loop is that generally that error will only affect a small number of APIs. Like maybe you have 100 APIs on your single service or something like that, and one of them has a blocking problem. So that means that if you block incorrectly, it's going to affect that one API because that API is going to start returning errors. However, if you're blocking and that blocking happens to block the entire event loop, suddenly all of your APIs stop working. All of your APIs are affected. So in my mind, I would rather live with one API being affected by an error than all of my entire application just going down because it's just locked up and the event loop's stuck. So yeah, that's why we're kind of considering using BlockHound and prod now that it's GA. So yeah.
Just maybe to add, because you can also add logging instead of throwing an error, discussing fallback.
Right. Yeah. So Sergey's comment was that you can basically configure BlockHound to perform logging instead of throwing an error. But yeah, that's an option. Although, again, like I say, I think I'd rather just throw the error, honestly. Yes?
The BlockHound initialization is static when you load the class.
Yeah.
Is there a way to configure BlockHound and say, okay, you need install only in non-prod environment? So we don't have access to the Spring environment. So I cannot check the profile, I cannot check.
Yeah, I think you could certainly defer the initialization of BlockHound. And Sergey, please correct me if I'm wrong. I think the BlockHound docs recommend doing it in a static initializer block just so that it's kind of the first thing that happens in your app. But I believe you can still do it later. Sergey, do you know if it will actually instrument the classes that have already been loaded?
Yes, it will.
Okay.
Instrument blocking code. The only thing is that if something happens with the initialization type, some blocking code, then you will miss it. But other than that, you can easily initialize data.
Yep. So just to repeat it for the microphone for everybody else if you couldn't hear, Sergey is basically saying that you can certainly enable BlockHound a little bit later in your startup cycle. The only kind of disadvantage to that is that it will miss any incorrect blocking that happens before that. But after that, it should be fine. Yep. Other questions? Yes?
First, can you show the GitHub?
Oh, sure.
And the second is, how do you know?
I went past it. Go forward, forward, forward. There we go.
How do you know which scheduler to subscribe on? Is it always the bounded elastic, or?
So that would kind of be like as far as, okay, so the question was, how do you know which scheduler to execute the blocking calls on? Generally, the recommendation, so Reactor has the bounded elastic that's always kind of available to you, and that's what you can use. However, it's really up to your application to determine like which event loop, which scheduler you want to use. You can certainly create another scheduler if you want. There's a way to create another bounded elastic scheduler that's not like the global one if you wanted to isolate calls in that one. And you can do that, I think, I can't remember the parameters of bounded elastic, but it has some certain defaults as far as what the limits are for that. So you might want to create a new bounded elastic scheduler with bigger limits or something like that in your application. Yeah. Sure.
What's the difference between the subscribe on scheduler and publish on scheduler?
So subscribe on will basically affect everything that's upstream. It will affect where the subscription actually happens, so where the stream basically starts producing data. And then if you were to say chain multiple subscribe-ons, the one that's furthest up the chain will win. Publish on the other hand, affects how values are emitted downstream for all the downstream operators. So if you're doing like in a from callable, that happens on subscription time. So you need to use subscribe on to schedule that callable. However, if you're doing blocking work a little bit later downstream, you could use publish on to change the scheduler at that time to go to a different scheduler to execute blocking after that. And then if you wanted to switch back after it, you could put another publish on after your blocking call, something to switch back if you needed to. Yeah. Yes?
So I noticed that you were just passing a string, which is inherently thread safe.
Mhm.
And you're passing something that isn't thread safe, or you're relying on some thread safety causing thread safety to reflectively happen or accidentally happen on the things that are coming back, or the objects that you create on one thread, returning them, or should they be thread safe also?
Right. So the question was really about immutability, I guess. Basically, I was using a string in the demo, and the question is more along the lines of what happens if you don't have an immutable object or something like that in your stream. Generally, yes. If the same stream is going to be bouncing tasks between the different schedulers, you're going to be hopping threads, you're still reliant on kind of the JVM's handling of that, of like the Java memory model, basically. So if you're using an object that doesn't use volatiles, doesn't use synchronized, like hash map or something like that, you'll still see the weird effects of that. Like if you weren't to synchronize that between the two threads, you could potentially do that. Like some changes might be visible only on one thread and not on another. So you're still reliant on that. So theoretically, as long as your object that you're passing, your data object, is thread safe or immutable, preferably immutable. But if it's thread safe, you're relying on those thread guarantees as well. Yeah. Anybody else? Any other questions? All right, yeah. As far as the style, the threading style, whether you're choosing a thread per request or the Webflux style, the parallel event loop, I highly recommend you look at, I think the talk was titled The Value of Reactive System, that was given by Stefan Maldini and Violetta Georgina. They go over a lot of comparison, basically comparing Webflux with WebMVC. And they have a lot of charts and a lot of description about which one behaves better and as far as like the call counts and things like that. So definitely recommend watch that talk, and I think that'll answer your question. Yeah. All right, I think that's about it. Again, you can always reach out to me. Reach out to me on Twitter. I have direct messages open right now, so if you have any other questions, you can follow up with that. Cool, thanks everybody.